Hi, so welcome to today's video lesson, and today's video lesson we are going to be taking example as touching conservation of energy. All right, so if you have not subscribed to this YouTube channel, kindly do so now. All right, it costs you nothing, but it means a lot to me. All right, so let's start with an example. Let's say that a stone of mass 0.5 kg is thrown vertically upward. Let's say that we throw a stone vertically upward. Okay, let's say that a stone is thrown vertically upward. Okay, like this. Good. All right, so this is the apex. This is the highest point it's gonna ever get to. Okay, good. This is the ground level. Okay, so it is thrown vertically upward. What is the mass of this ball? The mass of the ball is 0.5 kg. Okay, good. All right, then it is thrown with a particular velocity v equals let's just say 10 meters per second. So it's thrown with a velocity of 10 meters per second. Now the question now is to find the potential energy at the greatest point. So as to find the potential energy at this point, and then we also ask to find the height. Okay, now I want you to listen very carefully. Now at this point, as the ball or the stone, as the stone goes up, now it's ascending against gravity. Gravity is pulling it down. It's going against gravity. The stone is going against gravity. So as it goes, it begins to reduce in speed. So it goes, then by the time it gets 10, it has reduced the speed to 0, then it drops down back again. Okay, good. So that means at this point, the speed is actually 0. At the maximum, the speed is 0. But at the minimum, here, just before it hits the ground, this is the speed, 10 meters per second. Okay, good. Now the question is, what is the kinetic energy here at the top? So at the top here, since v equals to 0, so an half mv squared, v squared 0, 0 multiplied by everything there is 0. So kinetic energy at the highest point here, kinetic energy at the highest point there is equals to 0. Good. All right. So what is the kinetic energy here? Good. So what's the kinetic energy here? The kinetic energy here, just before it hit the ground, just before now, launched with a velocity of 10 meters per second. And so that has to be equals to, remember that kinetic energy is equals to what? Half mv squared. And that's half multiplied by, what's the mass? 0.5. I'm going to write that in fraction. That's 1 over 2 multiplied by, what's our speed? Our speed is 10 squared, that's 100. So let me just write that as 100. 10 squared is 100. So 2 here, 1, 2 here, 50, right? 2 here, 1, 2 here, 25. Okay, good. So kinetic energy is actually equals to 25 joules. Okay, so 25 joules. Okay, good. That is the kinetic energy at that point. All right, good. Then remember that the conservation of, now before we go there, let's find the potential. Can we find the potential energy here? No, we can't, because they didn't give us the h, so we can't find the kinetic energy here. But we know that at this point, because there is no height, just at the ground level, there is no height, potential energy here has to be 0, because mgh, h is 0. So at the ground level, potential energy is equal to 0. Okay, now remember that from the conservation of law of conservation of energy, that potential energy plus kinetic energy is equal to a constant. At any point is equal to a constant. Now, what is the constant? Now, do we have potential energy and kinetic energy for a particular point? Yes, we do, for the ground level. So for the ground level, potential energy is 0 and kinetic energy is 25 joules. So you have to look for that level where you have both your potential energy and your kinetic energy. Now the ground level, this is at the ground level. At ground level. So don't mind my abbreviation. This is at. Okay, so you have potential energy is 0 plus kinetic energy is 25 joules. And that's equals to what? 25 joules. So that means the constant that we're looking at is 25 joules. That means at every and any point in this problem, the sum of the potential energy plus the kinetic energy must be equals to 25 joules. That's what that law is saying. Now, we are asked to calculate the potential energy at the top. Now, at the top, kinetic energy is already 0 at the top. Okay, good. So we have to look for potential energy. We have to look for potential energy at the top. So can we basically do that? Yes, we can do that. Now, all right. Then remember that this same law we're going to use for the at the top. So that means potential energy at the top plus kinetic energy at the top must be equal to 25 joules. That is the law, right? Since at the bottom is also 25 joules, then at the top too it has to be 25 joules. Here kinetic energy is already 0. Okay, so we're looking for potential energy. Then potential energy plus 0 equals to 25 joules. So that means that potential energy is equal to 25 joules at the top. So potential energy at the top is equal to 25 joules as well. All right, good. Now, how do we now find the height? How do we find the height? Now, we already said that potential energy is what? The potential energy at the top is 25. Okay? So I remember that potential energy is equals to what? mgh. And we're looking for the height. That's the maximum height at the top. And at the top, potential energy is equal to 25 joules. And what's the mass of the stone? The mass of the stone is 0.5 kilogram. 0.5. I'm going to write that in fraction. 1/2 multiplied by acceleration due to gravity is actually 10. Then multiplied by h. And so we have 2 here, 1, 2 here, 5. And so we have 25 equals 5h, right? And 5 divides both sides. H, 5 cancels out 5. And so h equals to 5 meters. So h equals to 5 meters. So the height at which this potential and this stone gains a potential energy of 25 joules is actually 5 meters high. Okay, good. All right, so this is how to solve problems as touching kinetic energy. All right, so let's take another example. All right, let's say that a body of mass 2 kg falls from rest, then falls to the ground. Okay. Now it falls through a height of, let's say, 20 meters. So that is the height, 20 meters. And then it came to rest after being um after penetrating the sand like this, the sand, so that means it sank into the sand. It sank into the sand. Okay, let me. It sank into the sand. It sank into the sand, and that's for 0.5 meters. All right, good. Now, calculate the average force. Looking at force exerted by the sand in bringing the body to rest. That's a very, very serious question. So I have to calculate force that brings this body to a rest. So remember that this body is actually 2 kg. So what force is stopping this that brings this ball to rest? First, we have to look at energy. Energy. Remember that um, energy is what? Force times distance. Good. So just put that in mind. Force times distance. And remember that we have a distance here. So that means we have to find the energy at this point. So if we can calculate for the energy at this point, we then would be able to calculate for the force, because we know the energy, we know the distance, then we can find the force. Okay, I think that's better. So that we do know that this ball is at the maximum height, and at maximum height, the speed is equals to 0. Okay, so but the speed here is what we don't know, because as it falls from the ground, it accelerates. So this is g, acceleration due to gravity. It accelerates and it increases in speed from 0 up maximum height. It increases speed. Then, so if you have not seen a video on fundamentals of motion, you have to see it, because this is where this question is actually coming from. So they fused the 2 questions together: fundamentals of motion as well as potential and kinetic energy. All right, so let's see now. So we have what are our parameters. We have our u, which is the initial, let me call this initial speed, because that's where it started from. Then we're going to call this v, final speed or final velocity. So we have initial velocity, which is where we're starting from 0 meters per second. Then we have our final velocity, which is what we don't know. Then we have the height. The height is 2 meters. Height 20 meters rather, 20 meters. And then we have our g equals 10 meters per second squared. Okay. All right. Then, now from these parameters that we have, can we calculate our v? Now, from all the equations of motions that we have, v equals to u plus at, v squared equals to u squared plus 2gh, let me call this g, then h equals to ut plus half gt squared. So which of this formula can we use to solve this, to find our final v? So if I use this first formula, I don't have a t. So that means in this question there is no t. So therefore all formulas that has to do with t are going to be cancelled. So I can't use this, and I can't use this either. I can't use this either because of the t. So that means the only formula option I'm left with is v squared equals to u squared plus 2gh. That's the only option I'm left with. Okay. Now, since this is falling under gravity in this direction, and gravity is also in that direction, so the acceleration due to gravity is positive. So, but if it be going up against gravity, the acceleration due to gravity is negative. But this case is positive. Okay. So we have v. What's our v? That's what we're looking for. V squared equals to, what's our u squared? Our u is 0 squared plus 2 multiplied by G. Our G is 10 multiplied by H is 20. So we have V squared equals to this, all of this is 0, so that's gone. Then 2 times 20 is 40, 40 times 10 is 400. Okay, good. And so that's 400, and so we have V equals to square root of 400. So I'm going to leave this like this, 400 meters per second squared. So remember that we are looking for the energy at this point. So it's kinetic energy you're actually looking at, because if you say potential energy in this place is 0, and remember that's falling from a height, so and it has to do with motion. Remember that kinetic energy is the kind of energy that is due to motion, so it's energy that is due to motion. All right, so we are looking for the kinetic energy at this point. So kinetic energy is what? Half mv squared. Half mv squared, that's kinetic energy, equals to half multiplied by what's the mass of the body. The mass of the body is 2 kg. 2 kg multiplied by the speed, the velocity is square root of 400 squared. So that is why I left that square like that. Square cancels out square root, and so we have half cancels out half. So kinetic energy basically is just 400 joules. So that is the energy by the time it gets to the ground. So by the time it gets to the ground, so let me just draw another diagram. So by the time this ball gets to the ground, it has a kinetic energy of 400 joules. So remember that energy is the ability to do work. So now so this ball does a work by going through the sand 0.5 meters. Remember that energy, which is work done, is equals to force multiplied by distance. And remember, we're looking for force. So what's the energy? The energy possessed by this ball is 400 joules. Pardon me. It's 400 joules. Then we are looking for the force multiplied by what's the distance moved by this ball into the sand? 0.5. So we're going to divide both sides by 0.5 to get our answer. And so doing that, I have my force to be actually equal to, what's wrong? Actually equals to 400 divided by 0.5, that's 800 newtons. So this is the force that we are asked to calculate. So you have to be open-minded when solving physics questions, because they can bring your questions from previous topics that you have done before and try to fuse it up with the new topic you're learning. And so that's the beauty of physics. All right, good. So in our next video, we'll be taking one more example to actually see. I think this video is getting too longer than I want it to be. So in the next video, we'll be looking at another example on this kind of example. All right, so do well to subscribe to this YouTube channel and share to friends that you think might actually find this video helpful. All right, bye.